Okay, so I guess we are going live. All right, so today I'm going to be doing a C speedrun basically. And as you might have guessed, this is not my laptop. This is my friend's laptop, and let's just make a C speedrun folder. Let's go there, and we will do everything there. Okay, no, 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 no. Not like this, like this. Yes, we are here. Okay, so we can just close this now. We can close it all, and we can now like start doing our thing. First of all, we don't want PowerShell, we want command prompt. And I just hope that he has, okay, yeah, he has GCC, good. I think I was the one who installed it, no problem. There's no warranty, no problem. Okay, so let's just, and I'm gonna be using W3 School's tutorial because why not? Let's just see if he has the Brave browser. Yeah, he has it. But I don't think he will have the dark theme. So prepare to get flash banged because I'm not downloading any Chrome extensions for now. Okay, so yep. Let's just go to W3 School. Okay. Well, I'm not doing web development. I'm not doing web development. I'm doing a C speedrun. So let's just start here. So let's start it. I have to print a hello world. Okay, so let's just do that. Code get started dot C, and we have our first file, and the objective of this file is to print simple hello world. That's it. So the way we do it is simple. We just include, wait a second, just let me zoom in. Yeah, dash include s sorry stdiu.h int main. The main function is important, and we do simple return 0. And let me zoom out. I think this is fine. Print f and hello world, and do not forget the semicolon. So we just compile the C file to get an executable, and then we run the executable, and we have hello world. So that's it. We have the first file. Okay, so cool. Let's go to the next tutorial. Okay, let's go to the next tutorial. We have C syntax. So yeah, I already know about that. Let's go to the next tutorial. C statements. Okay, yeah. Let's go to the next one. We have a C output print text. Yeah, we have that already. No problem. Let's go to the next one. We have new lines. Yeah, okay, yeah, we have new lines. So let's do that. Hmm, should I code a new one for it? New line, because it's literally just like one character that kind of like helps you, you know. So let me remove this one, because these are like so trivial tasks. Let me just get on with it. So like what is happening right now is that they're trying to say like if I try to print this twice, basically, if I try to, okay, come on, what? Since this is not my laptop, the end button was not working. I have to click the shift in order to do it. Okay, so basically, if I compile this new line uh, file into an executable, and yeah, as you can see, this does not get printed on the next line unless I specify it. So that's something. Python gives you that by default. That does not mean that Python is better. That only means that Python gives you more tools than you know of. Okay, so Python has already provided you with that. But someone who's learning C, they have to know about the new line. Okay, because we build everything on our own here, almost everything. So new lines, that's it. Escape sequence, backslash. Okay, let's not focus on that. Comments, yeah, I know about that. Variables, all right. Let's get there. Integer, float, characters. Let's do that. So type variable name value int. Yeah. That's how it works. I know that. Okay, so let's do that. Variables. Variables dot c. Okay, sorry. Variables dot c. Slash include. Yes, I mean, like we only need one file so far, but I think as we like progress, we will need more. Return 0. Okay, so first we will get an integer variable. Let us call it age. Like 10, no, about 18, and we get a like float marks. How about 19 and a half? Yeah. And character, let's call it grade because grades are well graded in characters. Let's say A, or how an S class. If you know about okay, if you know the reference, you know it. No problem. So print F, and we can just easily like print it like age is equal to percentage I for the integer, and we can just give it the age variable here, and you can see I can just variables, and yeah, there we have it. Similarly, we'll just do it for other variables. Marks is equal to percentage F. I think that's how we do it. Like, okay, maybe it's percentage F. If it is not, we will check it out. So I can just marks. Sorry, the code will only go till here, and semicolon print F. After that, we have grade is equal to, well, character C grade and colon, sorry, semicolon and GCC. So you can see I was like writing the Python interpreter because I have a bad habit. That's not a bad habit, just mark. Okay. So it's not percentage F, I think. Unexpected before marks. Okay, so okay, yeah, I did not provide a comma right here. Hmm. Yeah, as you can see, but no new line characters. So like I need a new line after this, and I need a new line after this. Oh, sorry, this is the old executable, the new executable. Yeah, as you can see. So actually, I've not specified the number of digits I want after the float, so it's like giving me all the digits like 1, 2, 3, 4, 5, 6. I only want like 2. So I think the way I do it is dot to F. I think that's how it's done. And now it will only give me like 2 digits after the decimal. Yeah, 9.50, no problem. Let's just say I don't even want that. I just want only one. Because people don't like actually get concerned about 2 digits in marks. Like it's only 1 digit, right? Unless you study in some like prestigious college, not in colleges. I think it's some institutes that give like 0.25 marks. Like what is that? It's like it's either one. 0 or point 0.5. It's not 0.25. Okay, whatever. It's their problem. Fine. So that's the variable section, format specifiers. Yeah, I think I already did that. Change values. Okay, how do you change values? Oh yeah, I used to specify values, not a big thing. Multiple variables. Yeah, not a big thing either. Variable names. Yeah, you can name them. I get it. Real life example. Yeah, I already did that. No problem. Okay, let's go into data types. So we have integer, floating point, and character. Yeah, I already did that. So a character is basically what? A character, like just one character, that's it. And you have to store multiple characters, you have strings. Okay, yeah, I know that. So let's just make a string dot c. Okay, so let's just copy some code from here and let's just do the string. So of course, a string is a array of characters. So what for those who don't know what array is, I think we will come across it in no time. Like for example, have a name. Now a name cannot be stored in a single character. So the way we can store a name is like this. So that's my name, by the way. And you can just easily print this using this percentage s and then provide the name. Yeah, but I think there is something missing here. Let's see if it works. Yeah, it works. Somehow it works. So I guess nothing was missing, maybe. Because I think I have to provide the address. Well, I think we'll encounter addresses later, so no problem. There. Okay, then we have numbers in integers and floating and double. Well, it's for double precision, but it's not that big of a deal. Decimal precision, yeah. Memory size, yeah. So an integer basically gets stored in 2 bytes, 2 to 4 bytes. That depends, I think, on the compiler. And I'm using like the GCC 6th version. Yeah, you can see like I'm using GCC. I'm using the 6.3 version of GCC. So yeah, it depends on the compiler. So an integer can be from 2 to 4 bytes. A float number is 4. A double is 8. And the reason is because a double stores like 2 times more, I think, precision pointers than a floating point. A character is a single byte. Okay, so yeah, cool. Let's keep moving. Real life examples. Type conversion. So yeah, that's a cool thing. So what is a type conversion? Basically, you convert uh, an one type to another type. So there are two types of conversions, implicit and explicit. I actually forgot. Like implicit is automatic, explicit is manual. So can you give me some examples of implicit conversion? Implicit conversion is done automatically by compiler when you assign a value of one type to another. For example, assign int value to floating point. Okay, so let's do that. Okay, so let's do type conversion. Type conversion dot c. Let's copy some of the code here, the boilerplate code that we need. Okay, so for example, like let's show the implicit conversion. It's done by compiler. By the way, I think we should leave the link of the website in the description. Okay, let me just do that. You know what? So description dot txt. So yeah, let me just provide you the link. So it's basically going to type conversion, but basically the C link is what I want to provide. So it's the index page. Okay. So yeah, there you have it. If anybody wants to visit, sorry, I was on type conversion. Yeah. So implicit conversion is basically, let's go back. Like for example, I make this float, FLOAT, like grade, but I don't give it a floating point value. I only give it like 10. Okay, but it will convert it to a floating point number, and vice versa. Like for example, int number, but I give it 10.10. I think it will convert it as well. So yeah, let's come here and let's test it. Printf uh, grade is well, percentage f. I only want up to 2 decimal points, and number is equal to percentage I, and grade and comma number in that order. So yeah, let's let me do, sorry, old habits. Well, it's a new habit actually, but yeah, it has been some time since I've coded in C. So as you can see, the grade was 10 but was converted to 10.00 because floating point 2 digits after the decimal as I've specified, and the number 10.10 was converted only to 10 because integer can only store that. So that's implicit conversion. Explicit conversion is something that we specify to convert this number to another type. So that's the implicit. Explicit conversion is right here. So what happens is that you have to tell uh, that you have to convert this thing to float. You know, so for example, here, I think what will happen, okay, I don't think these are good examples of explicit conversion, but I think I can find better examples of explicit conversion. Uh, okay, for example, let's just say in explicit, mm, just give me one moment. I need to add it. All right, let's do it. For example, I have an integer number. Well, I cannot declare it twice, so let's just call this number 2. And I give it a value of 10. Okay, now, okay, no, okay, now I want to make this float. Okay, floating point number. And come on, man, number 2. Okay, so will it be converted to floating point? That's my question. Like, and I store it, because if I store it in a floating point, it will automatically be converted to a floating point. So that does not really make much sense. I think what will make more sense is if I print it directly after converting it. So let's just do that. Okay, let's just try to print this number directly after the conversion. And yeah, we have no errors. And we need basically a new line characters that separates these two. Let me just put one more to like separate the implicit and explicit. Sorry, there we have it. So as you can see, this one is the implicit conversion and this one is the explicit conversion. So basically, just by telling the compiler that convert this number, which is originally an integer, to a floating point, it will convert it to a floating point. And I think they did not provide like the size of, because they should have. Okay, okay, they did. So let's just make one file for that as well. Like I was thinking about the size of function. So basically, what is the size of function? Basically, it tells you that uh, what size is being stored. Size, sorry, memory size. I think that's a better way to do it. Again, and you know what? Let's just try to remove that comment. Like, is there a way to get the boilerplate code? Okay, so we will use the size of. Okay, so you have to use percentage ZU. Okay, note that percentage ZU format specify the print the result instead of this is because the compiler expects size of operator to return a value of type size T. Okay, okay, okay. So ZU basically prints type size T. Okay, so I think should I put that percentage ZU prints uh type size underscore T. So basically what is that every like variable is specified like previously, like for example int number, all of them are specified. Okay, so this is a integer type, just like that. The number that we are getting from the size of like variable is size underscore t type, and that needs, instead of like just like an integer needs like percentage I or percentage d, it needs a percentage ZU. That's it. So just need to go to the end and give a semicolon. Okay, so percentage ZU, and we will know the size of the integer, which can be 2 or 4 bytes. I know. We have There we have it. So our integer is 4 bytes. This compiler makes it 4 bytes, as you can see. It can be 2 or 4 bytes. A character will always be like 1 byte. So I think I should make it like nicely formatted. So I should say integer size is this, and I should make a few more variables. Char uh, grade is a or s for the fanboys. Uh, Float. mm, no, not percentage. Let's just call this pi. Yeah, pi 3.14, an approximation of pi. It's the double. So what happened? Yeah, nothing. So pi, and we can specify uh root 2. It is if I remember correctly 1.414, if I'm not wrong. Let me just check it correctly. Quickly, root 2. So root 2 is it's oh my god. Square root of 2 is basically, oh, come on, just give me the answer. Can I do it here? Like, come on, man. Like, it has to be a calculator. Calculator. Square root of 2. What happened? How do you calculate this thing? Okay, it's 1.414. Fine. I was right. Okay, so what happens now is that I will print it for all variables. So integer size, we know we need the character size, which is I have to provide the read variable here. Next, come on. So floating point, and there's a reason why it's called a floating point because it's not fixed, basically. Let's not get into that. It's the computer science thingy, and finally double size. So it's basically the double size of the floating point, root 2. So if I do the compilation now and then the execution, as you can see, we have different sizes, but it's not nicely formatted. So let me just use the new line character to format this nicely and make it, look good, basically. That's what front end developers do. That's the paragraph. So you have integers of size 4, floating point of size 4, character of size 1, double of size 2. Sorry, double of size twice the size of floating point, that is 8. So that's good. We have this and that, but we are still not getting into like the interesting bits as of now. But we will, don't worry, we will get into them. Then we have constants. So basically, const is nothing but a number that cannot be changed. If I try to change it, I will get an error. Let's not forget about C operators. Yeah, plus, minus, divide, multiply. Boolean, yeah, true and false. They are used in like if else conditions. And finally, we have the if else conditions. So yeah, let's do that. Okay. If else dot c. I don't even know if there's a dot v language. I don't even know. So if else. So let's just get what it L U D E standard input output dot h, and we got the main function void, and we are returning 0, nothing more, nothing less. And the let's make a cross condition. Okay, so is is 18. Let's just say is 18 and make it true, or make it is 18 plus. I think that's a better one. And let's make that true. And if is 18 plus, and I think we have to do this. Yeah. So print you can drive else, sorry, else print f you can drive. Yeah. If else, and we have an error. So yeah, it's right here. I did not provide the semicolon right there. Yeah. And we still have an error. Let's see. So it says that okay, yeah, it's a Python habit. I did not specify which type of variable this is. Okay, what we have next is unknown type. Oh, it's not, I think it's capital B. Yeah, just a second. Let me see. So it's bool. Where it is bool not present. It's bool not present. Like seriously, is bool not present? Let me just comment this code out. Let me know if this bool is even present or not. Here's bool. What it says unknown type name bool. So how are they doing it? I think they have done similar things like me. So what is the difference? Like it's exactly the same according to me. Let's just see if this one runs. So you can see, so they cannot recognize me. Okay, no problem. We will do it the other way around, so we will make it an integer instead. We'll say age variable for the bool. So 32. And now what we will do is, yeah, if age is more than or equal to 18, then do this. So as you can see, we have one problem for this token, and I don't think, yeah, this is not used. Yeah, this read is not used. And we compile. Cool. So next is the executable file, and you can write. It works, as you can see. And if it goes below 18, like if it is equal to 18, it will work, no problem. But if it goes below 18 to like 17, then it will go into the else condition because it's not true. So you cannot write, no problem. Oh, okay, so if else is done, switch statements, kind of like if else. Then we got a while loop. Okay, let's do that. Let's do a while loop. Let's do loops. Let's do four loops, while loops, and two while loops in one go. Okay, while loops, two while loops, and four loops in one go. Let's do that. Okay, then we'll move on to break and continue. So loops dot c. Okay, so let's do them all in the one go. Okay. Hash include. Guys, I'm just gonna do one while loop, and then I'm gonna call it a day for now. Because I think I'm kind of getting tired. Yeah. Okay, while 5 is less than 10, that is the condition. I is equal to I plus 1. I can just do I plus plus actually. But let me do this like the simplistic way possible because I think that's what we're trying to achieve here. I is the variable. So GCC loops, and we got, yeah, I did not put a new line character there, so that's why. Let me just correct that. As you can see, it prints, so let me call it a stream for now. We'll continue it maybe in the later video. For now, this is it. Bye.